is for Pre-Cal Week 8, Task 2, over sequences. So you may or may not have remembered sequences from Algebra 1 and Algebra 2, but a sequence is a set of real numbers in a specific order. For example, if you like a specific order would be if every time you wake up in the morning, you make your bed, then you brush your teeth, then you go to the bathroom, then you change your clothes, then you go eat breakfast. That is a specific order of events. Now, in your morning routine, unless it really has to stay that way, doesn't really matter if you do things out of order. But a sequence is where things do absolutely matter, and you have to do them in the specific order that you've been given. Each number in a sequence is called the term. So, an arithmetic sequence is one in which the difference of any two terms is constant. There is a common difference. So, you can think of an arithmetic like a linear function. So the formula for an arithmetic sequence is a to the n, where n is the term number or total number of terms, equals a to the 1, so the first term, plus the terms minus 1 times the common difference. And then all of those things that you may or may not remember are listed down here. So a to the n is the nth term. N is kind of like the letter x. We just use n for sequences. But it can also mean the last term if the sequence does end. A to the 1 is the first term. N is the term number. So in the example 1, 3, 5, 7, this is the first term, second term, third term, and fourth term. The common difference is the change that is being made from term to term. So here we are adding 2, adding 2, adding 2. So my common difference would be 2. A geometric sequence is one where there's a ratio between each of the pairs. So each number is increasing or decreasing by the same ratio. So instead of adding or subtracting, we are multiplying. That constant or the common ratio is denoted by R. So in our formula, we have a to the n for any term is the first term times that ratio minus the term before it, okay? Now, if you notice, both of these have an n minus 1 because they all matter on what was before the number before it, okay? I can't add on this example, I can add, but that was a weird pause. I can't add 2 to the number that comes before 7 if I don't know what number is before 7, right? If I know it's 7 and I know I've been adding 2, then I could very easily subtract 2. But if I'm supposed to add 2 to this number and I don't know what it is, I can't add to it. So that's where the n minus 1 comes from. So on this part, they're asking us to tell if these are arithmetic, geometric, or neither, and then if they are arithmetic or geometric, we are to find the next two terms and the common difference or the common ratio. So in this example, if I were to try to figure out where I am, so my common difference, if I take the first term minus the second term minus the first term, that difference is going to be negative 0.8. If I take the third term and subtract the first term, it's negative 0.018. So this is not going to be arithmetic because I am not adding or subtracting every time. So that's how you check to see if there's a common difference. Then, if it's geometric, you should be able to take the second term and divide it by the first term and get a common ratio. So then if I take the third term and divide it by the first term, I have a common ratio. That 0.1 would be my common ratio. So this one would be geometric. So what I need to do to figure out the next two terms is to multiply this by 0.1, and I get 0.00002, and then multiply this by 0.1, and I get 0.0000002. So if you notice, this one we are not adding or subtracting something to it, but we are multiplying, and that number is getting smaller, but by the same amount. So for the next problem, second term minus the first term, we have a change of 1/2. Third term minus the second term, we have a difference of 1/2. So this is going to be arithmetic, and my difference is going to be 1/2. Now, if I was subtracting, my difference would be -1/2, okay? Also, if it is arithmetic, it cannot be geometric. So if you find one, you don't have to look for the other. So then I'm going to add 1/2. So I would have 5/2, add 1/2, and I would have 6/2 or 3. Okay, so arithmetic means you can take the term, subtract it by the term that was in front of it, and you should get a common number every single time, so a common difference. And if it is geometric, I should take a term divided by the term that came before it to find the common ratio. So then the last one on this page, if I take this term minus this term, I get 4/15. If I take this term minus the term before it, I get 4/35. So this is not arithmetic because there is not a common difference. Geometric, if I take a term and divide it by the first term, I get 9/5. If I take the third term, divide it by the second term, I get 25/21. So it is not geometric. So this would be a neither. There's not going to be a common difference or ratio. Now, if you notice, all they're doing is adding 2 to the top and then adding 2 to the bottom, but they're not just adding the number 2. Adding 2, so that would be 9/11, and then 11/13. You could also say that they are taking the denominator and turning it into the numerator and then adding 2 for the denominator. Denominator to numerator, add 2. Denominator to numerator, add 2. So either way, but it is not arithmetic or geometric. It's just a nice pattern. So the next page, they want me to answer some of these questions. They're not all asking for the same thing. So they want me to find the common difference and the formula for the nth term if it is arithmetic in a sequence. How many terms are in the sequence? So, wow, lots of things going on here. Okay, so first, they tell me it's arithmetic, so I'm going to take a term and subtract the number before it. And I'm just going to double check that they haven't lied to me. A term minus the term before it. And so -8 plus 3 would be -5. So my common difference is -5. I've done that part. Find the formula. So a to the n, we don't know yet. A to the 1, the first term is 2. We don't know n, and my common difference is -5. So my formula is going to be a to the n equals 2 plus n minus 1 times, -5. Now, they want me to find n. If you notice right here, my terms, I have a1, a2, a3, a4. I skip a few, and then I have an ending number. So this is going to be my a to the n. It's my final number. So I'm going to put a -118 right here, and then simplify these pieces. So if I backwards distribute, I would have -5n plus 5. Combine your like terms, so -118, 7 minus 5n. I'm going to subtract 7 and bring all that over here. And then divide by -5. So the n would be 25, meaning it would take 25 terms in this sequence for me to get the number -18 in that sequence. So there must be 25 terms to get from 2 to -118 by subtracting 5 every time. So I start at 2, and it would take me 25 times of subtracting 5 to get to the number -118. This next one, all they ask us to do is find a12. In order to find a12, we need to figure out what we are working with. So I'm going to try, I'm going to try to see if it is arithmetic. So second term minus the first term is -6. third term minus the second term is negative 6. So this is arithmetic. My common difference is negative 6. A to the 1, we are starting at 10. They tell us here that n is going to be 12, and they want to know what a to the 12 is. So a to the 12 is going to be my first number plus my term minus 1 times my common difference. This is something you could completely throw into the calculator. You can also do it piece by piece. Oops. So 11 times negative 6. So 10 minus 66 would be negative 56. So in this sequence where we are starting at 10 and subtracting 6 every time, by the time we do that 12 times, we would get to negative 56. Keep in mind, as you're working through this, you might be going, okay, I'm kind of tracking, but I need some practice. So don't be afraid to kind of Google arithmetic or geometric sequences. And also know that you can totally use all of this part on your assessment. Don't be afraid to write some notes down and use that as you work through the problems. So find the difference if a to the 1 is negative 12 and a to the 23, wow, is 32. So my first number is going to be negative 12. I have an n value of 23 and a to the n is 32. We don't know the difference. So a to the n, so 32, is going to equal a to the 1 plus n, so 23 minus 1, times that common difference. And this is all coming from a to the n equals a to the 1 plus n minus 1 times d. So that formula up at the top. Okay. Also, they said d for difference instead of r for ratio, which is why I automatically hopped to this formula. If it said find r, then I would need a geometric formula. Okay. So I'm going to do some rearranging. So 23 minus 1 is 22. Move the 12. So 44 equals 22 times d. And then divide by 22. So my common difference for this problem is going to be 2. So again, this looks kind of complicated because we're kind of all over the map, but if you notice, I'm just filling in different parts of the formula up at the front. So I've used this one so far, but just filling in those different parts and solving for whatever's missing. The next 3 are going to be about geometric sequences. So now we're going to hop to this formula. So a to the n equals the first term times your ratio raised to the n minus 1. So find the common ratio and the formula for the geometric sequence. 9, then 6, then 4. So to find my ratio, 2 divided by 1 is going to be 2/3, and then 3 divided by 2, and by 2 and 3 and 1 I mean the term numbers. So my common ratio is going to be 2/3, so I found that. My formula is a to the n, a1, r, n minus 1. So my first term was 9. My ratio is 2/3, and then that n minus 1 is just a part of my formula that stays in my formula. So to find the 8th term of the geometric sequence, so I'm going to use that formula again. I'm going to need a couple things. N is going to be 8. They want a to the n because that would be plugging 8 in for n. I need to find, I can see a1 is going to be negative 1. I need to find that ratio. So to find my ratio again, the second term divided by the first term is negative 4. The third term divided by the second term is also negative 4. So my ratio is going to be negative 4. So a to the 8 is going to be negative 1 times negative 4 raised to the 8 minus 1, which we would simplify to 7. So that would be negative 1 times negative 4 to the 7, and that simplifies to 16,384. If you have a normal calculator, you could just plug that in. If you have a phone calculator, remember you can do exponents by turning your phone to the side. So I would type in -4, raise it to the 7, and then multiply it by that -1. Last question, find a to the 5th. If a to the 1, so this is good information, is 1/5, and r, so we are talking geometric because they give me a ratio, is 2/5. So they tell me a to the 1 is 1/5. They tell me n is going to be 5. They tell me my ratio, and they want a to the 5. So I'm going to plug in a n equals a1 r n minus 1. So a to the 5 is going to be 1/5 times 2/5 raised to the 5 minus 1. And I would plug all of that into my calculator, and I get 16 over 3125, or 0.005. So again, on these sequences, you are just using these formulas over and over again. You are plugging things into a calculator, or you're plugging all the parts that you know into your equation, and then you are simplifying or solving for the piece that you do not know.